So hello everybody. Normally you should be able to see my screen. I'm just confirming it's the case. Okay, fine. So I received the confirmation. So yeah, hello everybody and welcome to this third webinar of the day, so third session. So this is about how to build, train and deploy models with Amazon Sagemaker. So I'm going to continue on what Neil explained just before, and the AWS machine learning stack, and I'm going to focus on the second layer, which is about the ML services. And more specifically, I will speak about what is inside the white box here. So Sagemaker Studio integrated development environment and all the Sagemaker sub-services that are inside of the Sagemaker service. But before going too deep into the service, I'm going to take a step back and explain you again the machine learning workflow and how it looks like today. So on the left, you have first a prepare phase. So a first machine learning project will always begin with the collection of data and the preparation of this data. So we will transform the data, reformat it in order to be able to use then in the build phase an algorithm. So in the build phase, what we are going to do is to choose an algorithm or build it ourselves. So yeah, even if we want to choose one, it still requires a lot of expertise, because in this field, you know that there are a lot of algorithms from statistical machine learning to deep learning. So it can require a certain amount of expertise. Once the machine learning has been built or chosen, you then have to train your algorithm by using the training data that have been prepared. And to do that, you typically use an infrastructure, so basically compute, so servers with CPUs or even GPUs. And yeah, as a data scientist, you have to manage this infrastructure. So it's not something that we like to do, managing infrastructure, but yeah, you have to do it. So yeah, so once you have trained first algorithm, then what you will not have the right result at the first time. So what you will have to do then is tune your model, make iterations, train a certain amount of times, and then tune the hyperparameters typically and see which one of the models is best. You also have to debug the models and so on. So in the end, you will maybe make hundreds of iterations, maybe more, maybe thousands, and in the end, you will have a lot of training runs to manage, and it can become indeed finally a project on its own. So managing all these training runs. Once you finally choose so your model, and your model is ready to be put in production, you then need to deploy it. And to deploy it, again, you need some infrastructure. So typically servers in production. And again, as a data scientist, maybe you are not interested in managing this infrastructure. Then once the model is in production, you will probably need to monitor to see if the model still with time continues to behave correctly. So if there is no data drift, and if the predictions are still correct and have a good quality. And in the end, if the business application based on this model is successful, then you will need probably to scale your infrastructure. So basically, you see a lot of technical challenges and also infrastructure challenges on top of data science work. So what Sagemaker does for you, in fact, for all of these challenges, we have built a service that tackle this specific need. So for each So really from experimentation to production, you have a service that can help you. And that's what I'm going to demonstrate in the rest of the session. And basically, all these services are accessible from the web-based IDE, which is called Sagemaker Studio. So let's begin with the build phase. And with the build phase, in fact, you can do it in Sagemaker notebooks. The notebooks are a good way to share your work, to review your work, and to collaborate with other data scientists. So concretely, how it looks like. So data scientist will receive just a URL, and then he will be able to log into the platform. And yeah, because this is a data-centric environment, in just one click, I can arrive on my Sagemaker notebook inside Sagemaker Studio. So as you can see, if you recognize the logo here, so this platform is based on Jupyter Labs. So for the people who already use Jupyter notebooks, it should look familiar. So here you can see my environment, and what I have is a dummy notebook, I would say. So we're going to do a walkthrough this notebook to illustrate some of the capabilities. But what you can already see is on the top left, you have, so because this notebook is running on a virtual machine, it's running on compute in the backend. And as you can see here, you can very dynamically choose and adapt, in fact, the machine that is running in the background. So you have a bunch of choice here. So you can choose the vCPU, GPU, yes or no, so, and the memory. So you have, you can quickly, in just one click, change the compute that is in the background. You can also change the kernel. So this should be familiar to also Jupyter users. So just here we have kernels that are optimized for MXNet, for PyTorch, TensorFlow. So you can also on the fly change your kernel. And what is also very important and a nice feature that is asked by a lot of customers is that we can share the notebook in just one click. So you just, if I click here, create, so I can choose to have also a Git repo information included here. So in my case, I haven't created a Git repo at the moment, but it's possible, and you can choose to include the output of the cells as well. So yes or no. Here, for example, if I create it, you can see that I directly receive a link that I can copy and then share with my colleagues so that they can have a view on the same notebook. So basically what they will receive is a read-only version of the notebook, and they will be able to copy it locally in their own environment. But just in one click, you can share what you have done. So for the collaboration, it's really optimal. So let's continue with the left pane. And as you can see here, you have all the directories that are that I have created. So I have a bunch of directories with the file. So it's just like a normal directory structure. You have here, as I told you, so the possibility to connect it with a Git repository. You have then all the, I would say, classical Jupyter Labs tabs. So just here to shut down my kernels if I want, or the running images. The menu of Jupyter Labs, so all the help of Jupyter Labs. And then here, the small flask here is very interesting. It's a feature that we call a Sagemaker experiment. And here I have also a bunch of directories. And for example, if I choose this one, which is an autopilot experiment, if I click on that, I can see that all jobs I have launched under a certain experiment. So in this case, you can see a bunch of tuning jobs that have been done. And if I check here, you can see also, so this is also part of Sagemaker experiment. So this is really to classify, to have a nice structure for all your experiments. Then you can explore them. You can, for example, sort them via the objective here. You can see which model was best, and so on. So this is experiment. You have also here this small icon is for the endpoint that are in services. So it's more when the model is in production, then you will have an endpoint. The model will run behind an endpoint. I will explain that later in the presentation. You can have a view also on the production environment from Sagemaker Studio. So let's continue and use this specific notebook to illustrate some of the capabilities. So this notebook is a real simple notebook. It's about direct marketing with Sagemaker XGBoost algorithm. So a side note is that so I will share at the end of the presentation a list of links, and you will receive also the slideshow. So you will receive the link. But there is, in fact, on the GitHub a repository with a lot of notebooks that you can try yourself. So it's just a matter of following and choosing the right notebook. If it's a TensorFlow notebook, MXNet, or what you use. So in this case, I've taken quite a simple one for the sake of illustration. So what we do in this notebook is first, as in all the new projects and notebooks, you will have to download a bunch of libraries. So for the people that are data scientists in the audience, I assume you know NumPy, Pandas, Matplotlib, and so on. So I just download these things. Then we download the data set. So a data set here comes from this URL. What we do is we unzip it, and then you can have a look at it here. It's in fact a CSV file, but it's not very readable. So what we do is we use the Pandas library, which is the data wrangling library in Python, to show the data in a better format. So here we have the data. So these are the first lines of the data. So there are in fact more than 41,000 lines. We have just showed here the first 10 lines. And what we can see here, so how the data looks like. In fact, each row represents so a person. And you have each column represent a feature related to this person. So his age, his job status, marital status, education, and so on. So we have 20 features like that. And in the end, we have the last column is called Y. And this column is in fact the label. So this is what we want to predict. And what is it? In fact, it's so it's a yes or no. This person has accepted a marketing offer. So that's really the goal of here, this application. So it's a binary classification objective because it's yes or no. So there are two classes. And as you can see, a lot of people here answer no. So we have in fact more no's than yeses, because in general, people don't accept marketing offers. So we can have a look here, small analysis. We have 8 times more no's than yeses. And in fact, what we are going to do is to train this model with the label. And then the goal is that when the model is trained, that you will have, that you will be able to use all the 20 features as input data, and the model will predict yes, if yes or no, the person will accept the marketing offer or no. So this is really the goal of the setup here of the model. So then in the next cells, what we do is just transforming the data. So for that, it requires a bit of experience and data exploration. So I'm not going to go into too many details here, but what we can see, for example, here is that for student class, retired and unemployed, we put all of them in the same bag, because it makes sense that these kind of people don't have, maybe have less money, and so it's less likely that they will accept a marketing offer. So that's a bit the kind of transformation we do. So again, you can have access to the notebook later to see more in detail what has been done here. But what is very important is that after the transformation of the data set, we will split this data set into training, validation, and test. And we are going to put all of that in S3. So S3 is our storage, in fact. It's our storage model. So all of that, you just need to understand that what we have done here is just preparation of the data, and we have put all the prepared data into the storage service. So next, when we have prepared the data, the next thing is to choose an algorithm. And with Sagemaker, we have three main possibilities to choose the algorithms. It's first, as Neil explained a bit, we have 17 built-in algorithms. So for these, there is no coding required. All the things that you have to do is just choose the hyperparameters, and that's it. So it's really a built-in thing, and it's the goal to for you to be able to use the algorithm as fast as possible. So I've put some examples here. There is a more comprehensive list in the documentation, but so you can have a look at it later. The second option is that with Sagemaker, we support all the most famous deep learning framework, machine learning and deep learning frameworks. So you can probably recognize TensorFlow, Keras, PyTorch, and so on. So with this, what is going to happen if you want to choose these possibilities, that you will just have to bring your own script, so your own algorithm, and we'll put this script in a container. So it's a Docker container that we as Amazon have built for you. These are open source, so you can have a look at them as well. But from your script, it's very easy to use this model. It's really bring your own script. There are just a few changes to bring to your code, and then that's it. You can run on Sagemaker. The third option is bring your own algorithm and your own container, in fact. So this is for the people who have who are more comfortable with Docker containers and who want to have more control on that, so they can do everything themselves, and then they can run. Next to these three possibilities, you have also you can also in fact use machine learning algorithms from the marketplace. So these are algorithms that are created by third parties. So it's really worth having a look at them. And you can also use the Amazon SageMaker Autopilot service that I will demo afterwards. So basically with Autopilot, it's really an AutoML feature, and it does everything. So from the preparation of the data, feature analysis, building the algorithm, training, tuning, and so on. So it does everything for you. Once we have built the algorithm or chosen the algorithm, then it's time to train. So what are we going to do? How are we going to train? So basically, we're starting from the notebook, and after the preparation, what we are going to do is from there. So from SageMaker Studio. So I have here illustrated an Amazon EC2, which is my virtual machine. So this is really my virtual machine here with 2 vCPU, 4 GB of RAM inside SageMaker Studio. What we have done already is we have uploaded the data to S3. So this is already, this has been done. I've showed you the code. And what we are going to do from SageMaker, from the notebook, we are going to invoke a function, which is the .fit function. Should sound familiar to data scientists. So fit function is a function that we can find in a lot of data science libraries. And when I do that, in just one single line of code, a training infrastructure will be created just from this single line of code. So this is where Sagemaker is very, very, very powerful. So you don't have to manage the training infrastructure. So the training infrastructure will be a bunch of virtual machines. Again, you can choose the amount of machines. So here there are 2 on the slide, but you can choose more if you want. You can choose the size, so the type of the machine, so the amount of CPUs, the amount of GPUs. So just in one single line of code. What is going to happen next is that from a Docker container registry, which is here the Amazon Elastic Container Registry, which is the service of Amazon, which is doing about the same as the Docker Hub for people who know. We just download the container image. We create the container from this image. So in the container, there is also the algorithm is already built in. So in the case of this specific notebook, and then the training infrastructure will be ready to train. So what is going to happen next? Amazon S3 sends the data to the training infrastructure. Training is being done, and then when the training is done, it saves your model to S3, and that's it. So very simple. Then model lives in S3. The model artifact lives in S3 after the operation. So from a code perspective, how do you do that? Basically with these lines, I said one line, but yeah, here there are a bit more, but it's a single object. So it's an estimator object. In this object, what you have to define as parameters is the container. So in our case, in the case of this notebook, we want to use XGBoost because it's a nice algorithm for binary classification. So the container variable has been defined here. So as you can see, it's XGBoost with this version. Then what we have next is a role. So this is more for the security part. So in here, so the training infrastructure needs to have access to your data. And so this is so the security, so because the training infrastructure has to access data, you can have fine-grained access to this data by using this role. So it's more a matter of security. You have the input mode, so which is file, which means that when Amazon S3, when the data is sent from Amazon S3 to EC2, in fact, it's all the data is downloaded on the infrastructure. You have also the possibility to use pipe mode. So you will stream the data if the data set is bigger. Concretely, it will be when data sets will be very big that we will stream the data. You have the output path, so it's when the model will be saved to S3. You just need to pass a directory where will I save my data exactly. And then the 2 main lines is how many instances do I want, how many virtual machines, so how many of these EC2 instances I want, and the size, and that's it. So only with this you have your infrastructure. So I think it's the dream for a data scientist to be able to launch an infrastructure just like that in some lines of code. To continue on that, just to a side note, you can use also what we call spot instances. So this is here, I'm not going into too many details here, but just you have to know that at AWS we have unused EC2, so unused virtual machine capacity at all time, and this capacity can be used by customers at a very deep discount. So we just by adding these lines, you can save up to 90% of training cost. So it's worth having a look at it. So once the estimator is created, so I will just explain these lines after. But once the estimator is created, you just choose your hyperparameters and you call the .fit function as I explained you, and then the training is launched. you can see the logs here. And just as I told you, here you can see that training seconds 58 seconds, billable seconds 19, because I used spot instances, and I saved here in this specific training 67% of the on-demand EC2 pricing. So yeah, this is I think really good. Next, once the training is done, yeah, what you can do, just a side note here, what can be done also in Sagemaker is, because what you want to do after training is tuning, and you will probably iterate a lot of times with your model. What we have is what we call automatic model tuning, and you can pass to SageMaker some ranges for hyperparameters. So this is an example of 4 parameters for XGBoost. And SageMaker will explore the hyperparameter space in this range and try to find the best combination of hyperparameters. So that's a side note on automatic model tuning. So, okay, fine, we have trained, so which is very good. So again, if we train hundreds of times, thousands of times, we have the experiments here that can help you, classify, sort your different trainings and find the best tuning, the best job based on the objective, based on things you want. But this is experiment. And another nice feature is the debugger. So it's the SageMaker debugger. So when you train, so during training, it's also interesting to debug your experiments while training. So to do that, we can go a bit back here and see in our estimator what we have also defined is these lines here. And as you can see, in fact, what is the debugger doing? It's just collection of data. So it will collect data while training. So we call this data tensors, but these are metrics of the model. So while training. So here in my case, I have 2 collection configs. So the first one is metrics. So it's about the accuracy, etc., of the model while training. And you have also the feature importance. So this is an example again. So this is basically collection of data. And the second part here is about the rules. So you can also define rules. In this case, I've created a rule about class imbalance, because we have seen before the data set is quite imbalanced in the sense that we have 8 times more no's than yeses. And so this kind of imbalance could impact negatively the model and training. So with this rule, we can, when the rule is applied, it will tell you during training if at a certain point it affects negatively the training. So what is going to happen is after the training, you can in fact afterwards call a specific function, a debugger function, and in my case the rule evaluation status was no issues found. So it seems that the imbalance hasn't had a negative impact on my training. So again, these rules are, you have built-in rules, you can custom, I bring your custom rules as well. But yeah, this is really done, and this is, if I just go back here, as you can see, when I call the .fit function, the class imbalance is in progress. So in fact, the debugger job is running in parallel of the training job, and it's saving all the parameters in S3 while training. After the training, and after when the training is finished, what you can do is with the data that you have collected, you can make nice graphs like that. For example, here we compare the area under curve for training and validation, so you can have a look at that. We have also saved the feature importance. So in this case, we see, for example, that feature 1, which was about the jobs of the people, and feature 5, the housing, have more impact on the decision of the algorithm to decide if yes or no the person is has chances to accept a marketing offer. So let's continue after debugging. Then after debugging, we choose a model and we deploy it. So to deploy the model, again, very easy. I have even less code here. So you call this, so xgb.deploy. You have 3 parameters, an endpoint name, an instance count, and an instance type. So basically, when you deploy a model, you have different possibilities with Amazon S3. So the code that I just showed you is for the real-time endpoint. So with the real-time endpoint, what you have is basically this infrastructure will be launched when you execute this command. So again, very powerful. With just one command, you have a whole infrastructure that is launched. So this is really inside of Sagemaker. So it's managed by Sagemaker. And what you have is a bunch of virtual machines as well in an auto-scaling group. So auto-scaling group means that you can begin, for example, with 3 instances, and you can have you can scale up to 10, 20 if the load increases. So you have a load balancer in front of that, so to load balance the load to the different EC2 instances. And you have your clients, so customers, that can send their inference requests, so the input data, so basically the 20 columns with the person features, so the age, the marital status, and so on, and the inference endpoint will answer with a prediction, yes or no, this person will accept a marketing offer. So this is really so real-time endpoint. Then next to that, you also have the possibility to have a batch transform. So some customers are not really interested in having a real-time endpoint. In this case, if they just upload their data to S3 and then in a batch fashion, the algorithm will predict make his prediction and store the results back in S3. So these 2 options are really fully managed deployment. So this is one line of code. So that's really the power of Sagemaker. Then you have also 2 other possibilities, is to run the model on our container services. So you will do maybe a bit more work. You will manage the container itself, or really you can run the model anywhere you like. So you just grab the model from S3 and then you can make it run on your laptop, on a server, somewhere. So it's really where you like. Okay, sorry. So just a side note on another service which is called Model Monitor. So in the same object, so in the same function, sorry, so the deployed function, you can also add some lines here. And what is going to happen is, again, we are going to capture data, but now in production. So all the data that is sent in production, so all the requests here and response will be captured. And what you can do with this is compare, so with the time, so you will have all the requests that are sent in production to the endpoint, and you can compare these requests with your training data and see if these are still aligned, because if there is a data drift, or if statistical properties of the data change with time, or if features disappear with time in the data that is sent to the endpoint, the model can be negatively impacted. So with Model Monitor, you can really have the right data and compare it to the training set, so you can improve or correct your model with time. Okay, but with all of that, as you can see, you still have to write code. So maybe you don't want to write code. So let's have a look at the last feature, which is AutoML. With AutoML, what you have to do is just, so again, from experiment. So first, what you will still have to do is to prepare, to download your data, and nothing, so it's just the data here. So you don't have to prepare the data, so you don't have to transform it, or nothing. You just, again, split the data set and you upload to S3. That's it. Once the data is in S3, you can go to here, small flask, you click on create experiment. And here you have create Amazon SageMaker autopilot experiment. So put a name of the experiment. You put the source S3 bucket, so where your data is, the output, which is where my model will be stored, and then you choose the machine learning problem type you want to solve. So we support at the moment binary classification, regression, and multi-class classification. So you can choose the one, because if you already know what your problem is, it's better to choose it here. And from there you can choose, for example, the objective metric, F1 accuracy, or you can just use auto. And the service will figure out which kind of problem it is based on the data analysis. Click on create experiment, and then from there it will take some time to train a lot of training jobs. And here, so I've already run that. So basically the default is 250 tuning jobs, tuning jobs. And as you can see, a lot of things have been trained, so a lot of jobs. And in the end, you can compare them by objective, and you can choose the best model here. So the best of the 250 models is this one. Then what you can do next, after just to wrap up, is you can take some of the tuning jobs and you can compare them. You have a graph function here. Here, in my case, I just compared two hyperparameters. For example, here I can see that this specific circle here corresponds to this specific tuning job, and I can decide to maybe these three, I just say something, but maybe these three would interest me, and I can decide to have a more deep dive in these three models. Just before finishing on this, what is very important with Autopilot is that it's not a black box model, but it's a white box. And so you can see here, you can open the candidate generation notebook, and from there, you can see what the service has done exactly. So you can go through the notebook and see what the service has done. So it's really a white box. So let's wrap up. So what we have seen here in SageMaker Studio is the notebooks. So it's where we have worked during the demo, I would say. The experiments to organize, track, and compare your ML experiments. The debugger with the rules and data collection. Model monitor for when the model is in production. And to detect data drift and so on, and autopilot, which is the last one. So basically, again, the first slide to finish. So I tried to show you as much I could in the time I had. There is always more with SageMaker, so there are more features. So I invite you to have a look at the documentation, or anyway, if you have questions, or if you want another session, we are open to that as always. And I've put some references here for you to have a look. So SageMaker is part of the free tier. So if you want to try that for free, it's possible. So have a look at this for the conditions. SageMaker documentation. Very, very, very important is this one. So it's the GitHub. I can just quickly open it very, very quickly. And as you can see, these are all Jupyter notebooks with different examples, so TensorFlow, MXNet, Keras, and so on. So I invite you to explore that really. It's a nice point to start. And yeah, this one is here about the containers that are open source. So the TensorFlow container where your code will run. So everything is there. So I'd like to thank you for your attention. And yeah, so I don't know if we have some time to, because it's maybe the break now. So maybe we can answer the questions after.